Welcome to Lesson 6. Thank you for visiting, and for those who haven't subscribed, please do so. In this lesson, we'll be looking at two groups testing. For data that fits normal distribution, we use parametric statistics, and to compare the means of two groups, we use students' t-test. We are testing the null hypothesis that the means of two groups are not different. So in Excel, there are options in t-test that assumes equal or unequal variance. Therefore, we should first use f-test to test whether the two groups have equal or unequal variances. In Excel, the f-test is done as a one-tailed test, so direction is important, and you must remember to place the column data with the larger variance on the left. So let us try out the students' t-test in both Excel and PASS. So here we have the CFU data per 100 mil on Chromocult agar and also on McConkey agar. Let us transform the data by logging the data. Okay, and then we can drag it all the data. And let's look at the variances to see whether the variance is equal or unequal. In data analysis, Excel, you can check out this test to sample for variances. So variable range 1 and variable range 2 with labels, and the output range is here. So here you can see that the variance for the Chromocult agar is lower than the counts from McConkey agar. So we have to invert it to this side. And we'll do the same here. Okay, next we will repeat the step by doing the f-test. And now we will carry out this way with the data with less variance, smaller variance on the right. Then we'll paste the results here. Okay, then we can see that the P is more than 0.05, so there is no difference in the variance between the counts you obtain on McConkey agar and also Chromocult agar. If you were to use PASS, it's much more straightforward. Copy the data, and as usual, you paste it here. Select all and look for univariate tests. Two sample tests. First option here. You can immediately see your f-test is here, your t-test is here. So in your f-test, you can see that the P is more than 0.05, so there is no difference in the variance. If you copy, and then you can paste the results here. So you can see that the F value is similar. Okay, F value is similar, whereas the P for PASS is twice the P that you find in f-test, because the results here is for a two-tailed f-test, whereas this is for a one-tailed f-test. So once we have tested that the variances are equal, we can now do the group testing by looking at t-test assuming equal variances. Okay, so we'll look at variable 1, variable 2. The hypothesized means difference is 0 because we are testing to show that they are not different. So labels are here, and we'll place the output range. Can place the output range here. Okay, so this is the t-test, students t-test, assuming equal variances. So if you have unequal variances, you will just need to select the other option available. Here you can see the probability for two-tailed test is less than 0.05. That means the data from McConkey-Aga is different or not equal to the one that you obtained from Chromocult-Aga. The t-test is already available here immediately. So here you have both unequal variance here. So you can see that the equal, this is for equal, and this is for unequal variance. So the P is shown here. So if you were to copy and paste the results from past here, you can see that the t-stat is the same. T-stat value is the same, and the two-tailed test for equal variance, the probability is the same, similar here. In Excel, there is also an option for paired t-test. This is used when it concerns the same sample, usually in a before and after scenario. Finally, if your data that do not fit normal distribution, you may use non-parametric statistics. For example, the Mann-Whitney U-test to compare the ranks of two groups, or for paired groups, you may use the Wilcox signed rank sum test. Both these tests are available in PASS. In Excel, let's say if you have a data that shows bacterial counts before treatment and after treatment, you can easily just choose the data analysis and look for paired two sample for means. Similarly, just select variable 1, then variable 2. Hypothesized means difference is 0 because we are testing for no difference. Then output range is here. Okay, and you can see that the probability two-tailed test is less than 0.05. That means there is significant difference between the data before treatment and after treatment. So if you were to use PASS, paste the data first, and then under univariate two-sample test, there's a two-sample paired test. Then you can use this, and you can see that the t-test is here. There is also a Wilcox test here. You can copy it, and you can paste it. So for t-test, the t value is the same as this, and the p for two-tail is also the same. So there is significant difference between before treatment and after treatment. So in past, as you can see, the PET test also shows what you will get if you are using non-parametric testing immediately here. So if you were to try out the t-test again, you can see that the Mann-Whitney u-test is also available immediately within the same window. So it's very convenient, but you need to know which test is appropriate. Thank you very much.